Welcome to Learning Algebra from Scratch, a course from ultimatealgebra.com. This course will start you from level 0 and help you build a strong foundation. The course is designed to be extremely easy. In fact, designed so that a 10-year-old can understand. Okay, so let's start. Addition and subtractions in algebra. In algebra, we can only add things if the letters and their exponents following them are exactly the same. Example, we can add 2x and 3x because they both have x following the numbers. All you do is add the numbers and bring the common letter after the number. So we added the 2 and the 3 to get 5. Then we brought the x after it. The final answer is therefore 5x. Example 2. If you have 2x plus 3y, you cannot add them because they have different letters after them. One is y and the other is x. Example 3. If you have 2x squared and 3x cubed, you cannot add them because of the different exponents. One of the x is squared and the other is cubed. Example 4. You cannot add 3ab plus 2ac. Although they both have a, one is ab and the other is ac. They must be exactly the same before you can add them. Let's try these. Your addition and subtraction is good. This should be easy. Addition and subtraction of multiple terms. Like the way we added multiple numbers in basic math, we might have to add multiple terms in algebra. Let's try this. 2ab plus 5bc plus 3ab minus 2bc. Here, we take the first term, 2ab, and find out if there are other terms with the same letters after it. We notice we have 3ab, so we can add 2ab and 3ab to get 5ab. Next, we pick the 5bc. We look for another term with bc. Here we have negative 2bc. We work on 5bc minus 2bc to get 3bc. We cannot add 5ab and 3bc since they have different letters after them. So that is our final answer. Let's look at the invisible 1 in algebra. Example, AB is the same as 1AB. This means if we have just letters without a number in front, the invisible 1 is assumed. Example, 2ab plus ab equals 2ab plus 1ab, which equals 3ab. Again, 3ac plus ac will be equal to 4ac, because ac is the same as 1ac. We are now familiar with addition and subtraction in algebra. Please, I hope you have mastered it, because it is a step-by-step course, and we have carefully chosen the trend to make you good in algebra. Multiplication and division in algebra. When we learnt addition and subtraction in algebra, we said that letters must be exactly the same before you can add or subtract them. Example, we can add 3a and 2a because both have the same letters after the number. We also said we cannot add 3a and 2b because the letters are different. For multiplication and division, it doesn't matter the letters. You can always work on them. Example, 6ab times 2ac. The first thing you'll do is multiply the numbers just like we did in basic math. Multiply the 6 and the 2 to get 12. Now for the letters. We just look at the number of occurrences. Here, we can see that there are two a's. So we have a exponent 2. There is just one b, so we have b here. And we also have one c. Easy, right? Let's try these. Negative 3ab times negative 2bc. Here we multiply the negative 3 and negative 2. These are both negatives, so we have positive 6. Next, we look at the occurrence of the letters. The A occurs just once, the B occurs twice, and the C occurs once. So our final answer is 6ab squared c. When dealing with a lot of multiplications, please work on them from left to right. This is not a mathematical requirement. This will just make it consistent with operations like division and subtraction that require that order. Example, negative 2a times 3ab times 2b. Here, we will do the negative 2a times 3ab first to get negative 6a squared b. Then, we'll multiply this by the 2b to get negative 12a squared b squared. Division in algebra. In division, we are still looking at occurrence, but in a slightly different way. Let's look at 6a squared b divided by negative 2ab squared. We divide the numbers as usual. We divide the 6 by negative 2 to get negative 3. Now we say there are 2 a's at the top and 1 at the bottom, so there will be 1 left at the top. There is 1 b at the top and there are 2 at the bottom, so there will be 1 left at the bottom. What we are actually doing is this. A squared is the same as a times a. So we are just splitting the exponents and canceling the common letters. Notice that we did the same for the b. After the cancellation, we notice that we have 1a at the top and 1b at the bottom. Let's try another example. Here we have 15x squared y exponent 4 divided by 5xy exponent 6. First, we divide the 15 by the 5 to get 3. Next, we notice there are 2x at the top and 1 at the bottom. So our answer will have 1x at the top. Also, we see there are 4 y's at the top and there are 6 y's at the bottom. So there will be 2 y's left at the bottom. So this is our final answer. Addition, subtraction, multiplication, division, and the order of operation. When we have a question that has addition, subtractions, multiplication, and division, we have to employ the order of operations. Multiplications and divisions are done first, from left to right, and then addition and subtraction, from left to right. Example, if you have 2b times 4c divided by 6a. You will work on the 2b times 4c first, and then divide the result by 6a. Another example, if you have 3a divided by 3c times 4a, you will work out the 3a, divide by the 3c first, and after that, you will multiply by 4a. Let's look at a more detailed problem. When we have 2ab plus 3a times 2b divided by 3b, we know we have to do the multiplication and division first from left to right. We will work on the 3a times 2b first. Then we divide by 3b. Then we add our answer to 2ab. Please try the following. You don't have to solve. You just have to know how to go about it. Number 1. 4ab plus 2ab minus 2b times 2. You have 5 seconds to try it. Remember, multiplication and division first, and then addition and subtraction next, from left to right. Okay, so let's do it. You will multiply the 2b and 2a first. This will give you 4ab. Then you will add 4ab and 2ab to get 6ab. Finally, you will subtract the 6ab minus 4ab to get 2ab. Let's try another example. 10x squared divided by 5x plus 3y times 3y. Again, we do the multiplication and division first from left to right. So we can work on the 10x squared divided by 5x. We know how to divide it. This gives us 2x. Now we have 2x plus 3y times 2y. We do multiplication and division first. So we work on the 3y times 2y to get 6y squared. What we have now is 2x plus 6y squared. As we know, we cannot add these two terms because they have different letters. So that is our final answer. Introduction to parentheses. Parentheses is used for grouping. It normally helps us to write expressions in a short form and helps us to know which operation to perform first. Parentheses for order of operation. Let's start with a brief look at parentheses and the order of operation. When we have 2a minus 4a times 2, we know we have to do the multiplication first. We multiply 4a by 2 to get 8a. Then we work on the 2a minus 8a to get negative 6a. There are instances where we want you to work in a different way. Parentheses makes that possible. Let's look at the same example. 2a minus 4a times 2. This time, we will place 2a minus 4a in parentheses. When we do that, we are saying, perform the thing in parentheses first. So, we will work on the 2a minus 4a first to get negative 2a. Then, we multiply it by 2 to get negative 4a. Notice we got different answers. This idea is extremely important, especially in calculators. It is worth repeating that in the order of operation parentheses always comes first. Parentheses for grouping. Let's say we have 2a times 3b plus 2a times 4c. Notice we have 2a in both terms. We can rewrite it as 2a times, in parentheses, 3b plus 4c. Here, we bring the common thing out and the uncommon thing inside the parentheses. Let's look at some examples. 3ab plus 3ac. Here, we notice that the 3a is common in both terms, so we can bring the 3a out, and what will be left is b plus c. We put the b plus c in parentheses. Another example. We have 3ab squared plus 3abc. We know that b squared is the same as b times b. So the common things are 3ab. We can bring it out. We have one of the b's left and the c here. Our final answer is 3ab in parentheses b plus c. Remember when we learned the invisible 1? Let's look at another scenario of it. 2ab plus 2a. We notice that 2a is common to both terms, so we can bring the 2a out. This leaves b for the first part. For the second part, we have taken everything, which is the 2a. In a case like this, what we have left is 1. If we have 3b plus 3a, we can clearly see that the 3 is common. It is not always obvious that the numbers are the same. We can have a question like 6b plus 3a. It is not obvious that the 3 is common. If, however, we expand the 6 as 2 times 3, then we can see that they both have 3. We can pull the 3 out and have, into parentheses, 2b plus a. In most instances, it is very easy to identify the common numbers if your multiplication is okay. Parentheses expanding. The same way we can contract an expression, we can also expand an expression. For an expression, we might either want to go from 2ab plus 2ac to 2a into parentheses b plus c, or we might want to go the other way round. This is what expansion is all about. So say we have 2a in parentheses b plus c. We can expand this by multiplying each of the terms in the parentheses by the 2a. So we have 2a times b plus 2a times c. Since your multiplication is good, this should be easy. Exponents of terms in algebra. Exponents shows how many times a number or variable multiplies itself. Example, 4 times 4 equals 4 squared, which is equal to 16. So this is the exponent and the number here is the base. Laws of exponents. Exponents are governed by 3 laws, known as laws of exponents. Please take note of these laws. They make solving problems easier. Also note that these laws only work when the bases are the same. Law 1. The first law states that a exponent m times a exponent n equals a exponent m plus n. The first law is saying that when terms multiply, provided their bases are the same, you can just add the exponents. Example, a squared times a cubed equals a exponent 2 plus 3, which is equal to a exponent 5. Since we have done multiplication already, this is familiar. Law 2. The second law of exponents states that a exponent m divided by a exponent n equals a exponent m minus n. For the second law, we say that when terms divide, provided the bases are the same, you can simply subtract the exponents. Example: a exponent 5 divided by a exponent 3 equals a exponent 5 minus 3, which is equal to a squared. Here you'll see that we just subtracted the exponents. Note that it is possible to have negative exponents. Example: a exponent 2 divided by a exponent 6 equals a exponent 2 minus 6. This equals a exponent negative 4. Please take note of this. We will mention it again later. Law 3. The third law of exponents states that into parentheses a exponent m all exponent n equals a exponent mn. We are saying that when a number with an exponent is raised to another exponent, we can simply multiply the exponents. Example: into parentheses a squared all cubed equals a exponent 2 by 3. This is equal to a exponent 6. Notice how we just multiplied the 2 and 3. Important rules derived from the laws. Let's look at these common rules of exponent. You don't need to memorize these. Rule 1. Any term or number exponent 0 equals 1. Example: 2 exponent 0 equals 1. b exponent 0 equals 1. 100 exponent 0 equals 1. This is straightforward. We've already seen this in Lesson 1. Rule 2. The next important rule is on negative exponents. Negative exponent results in inverse. Therefore, a exponent negative m equals 1 over a exponent m. Example: 2 exponent negative 3 is equal to 1 over 2 exponent 3, which is equal to 1 over 8. So going back to the second example of Law 2, where we had a exponent negative 4, we now know we can write it as 1 over a exponent 4. Your ability to move between these two will make the next lesson easier to understand. Rule 3. Another important deduction is when the exponent is a fraction. The denominator of the fraction forming the exponent becomes the root of the term. The rule is a exponent 1 over m equals the m root of a. Example: 5 exponent 1/3 equals the cubed root of 5. Notice how the 3 became the cubed root. Again, a exponent 1 over 4 equals the 4th root of a. Notice how the 4 became the 4th root. Dividing a monomial by a monomial. Example: 6a exponent 5 divided by 3a squared. There are two ways to solve this question. The first method is to leave it as it is and use the second law of exponents to solve it. The second is to write it as a fraction question and reduce it. Method 1. The first thing we do is to divide the coefficient of the dividend by the coefficient of the divisor. Here, 6a exponent 5 is the dividend and 6 is the coefficient. We divide it by 3, which is the coefficient of the divisor. This will give us the coefficient of our answer, which is 2. The next thing is to subtract the exponent of the same letters. We already know how to do this from the previous lesson. We work on the a exponent 5 and a squared. We subtract their exponents and get a cubed. Method 2. Reducing of terms. First, write this in the fraction form. So we have 6a exponent 5 over 3a squared. As usual, the first thing we will do is divide the coefficients. That is 6 divided by 3 to get 2. Next, we know that a exponent 5 means 5 a's multiplying each other. A squared is a times a. 2 of the a's at the bottom can cancel 2 at the top. There will now be left with 3 a's at the top, which is written as a cubed. So our final answer is 2a cubed. Notice that we got the same answers. Method 1 or Method 2. Method 1 is normally used in general division questions and also exponent questions. Method 2 is generally used in fraction questions. You can use either. The only important thing is to be able to work back and forth with negative exponents. We know that negative exponents gives fraction. Example, you should be able to recognize that 2a exponent negative 2 is the same as 2 over a exponent 2. We did this in the previous lesson, the second rule of exponents. We'll be revising one-step equations for those who have forgotten. To solve for, let's say, x, we want to get rid of any number attached to the x. We do this by performing the opposite operation on both sides of the equation. The opposite operation of multiplication is division. The opposite operation of addition is subtraction, and vice versa. Let's look at 2x equals 4. We want to solve for x. We know 2x means 2 times x. We must get rid of the 2. Since it is multiplying, we will perform the opposite operation, which is division. We divide both sides by 2. The 2 will cancel out. 4 divided by 2 is 2. Therefore, x equals 2. Next, we want to solve x divided by 2 equals 4. Here, since the 2 is dividing, we will perform the opposite operation on it. We will multiply both sides by 2, so the 2 will cancel out. Then we have 4 times 2 to get 8. X is therefore 8. So we can easily do this. X plus 2 equals 4. The opposite operation of addition is subtraction. We subtract 2 from both sides. The 2 cancels out. 4 minus 2 is 2. Therefore, x equals 2. Radicals and exponents are also opposite operations. So if we have cubed root x equals 2, we will perform the opposite operation, which is cube both sides. Again, this will cancel out. 2 cubed is 8, so x equals 8. Welcome to another video from ultimatealgebra.com. In this video, we will be revising two-step equations. The most important prerequisite for this lesson and subsequent ones is the order of operation. You can check out that lesson in our pre-algebra course. To solve for, let's say, x, we want to get rid of any number attached to the x. We do this by performing the opposite operation on both sides of the equation, as we learned in the previous video. Let's say we want to solve for x in 2x plus 3 equals 5. We want to get rid of all the numbers attached to the x, so we have the x alone on one side of the equation. To achieve this, we must get rid of the times 2 and the plus 3. We use the idea of the reversal of the order of operation. So let's bring our order of operations. We are working from the bottom up. We will see that in this form, we must do the addition before the multiplication. We get rid of the plus 3 by subtracting 3 from both sides. The 3 cancels out. 5 minus 3 is 2. Next, we get rid of the times 2 by dividing both sides by 2. The 2 will cancel out. 2 divided by 2 is 1. Therefore, x equals 1. Let's look at another example. Solve for x in x over 3 minus 4 equals 6. We want to get rid of all the numbers attached to the x, so we can have the x alone on one side of the equation. To achieve this, we must get rid of the divided by 3 and the minus 4. Let's bring our order of operations. We are working from the bottom up. We will see that in this form, we must do the subtraction before the division. We get rid of the minus 4 by adding 4 to both sides. The 4 cancels out. 6 plus 4 is 10. Next, we get rid of the divided by 3 by multiplying both sides by 3. The 3 will cancel out. 10 times 3 is 30. Therefore, x equals 30. In most instances, for two-step equations, you will work out your addition or subtraction part first. Then you will work out your multiplication or division part next. This brings us to the end of this video. Have a great day. Goodbye.
Have you wondered if there is an easier, fun, and quicker way to master algebra? If you are like thousands of students we've been helping, I'm sure you have. The good news is there is, and you will get that today. Hi, I'm an engineer and the creator of the Ultimate Algebra course. A few years ago, I was just like you. Maybe a little better, maybe worse. My algebra sucked. I was spending 5 hours learning algebra every day to bring my grades up. Most of this time was just wasted on watching terrible videos that only made me more frustrated and almost guaranteed me failing my next test. You know, class was not good. If it was, I wouldn't have been watching these videos in the first place. I won't say my teacher wasn't good because I genuinely don't know. What I can say is, at the end of the math class, most students were zombies. Okay, a little exaggeration, but I really felt like I died and resurrected after that class. Algebra must not be this hard for you because UltimateAlgebra.com gives you an easier way. In fact, our Algebra from Scratch course helps students understand more algebra in 2 hours than they have their entire life. We've converted math into a recipe. Yes, dummy proof. You take a question, you follow the steps, and you get the answer. In most cases, we've taken the math out of algebra. Don't take my words for it. Listen to what other students are saying about the course right here on YouTube. Ebony Johnson says, I have always hated math and I still do. In high school, I never understood this mess. But now, finally as an adult, I find you on YouTube and you help make it easy. Thank you so much for breaking this down. Samuel Lewis, who is 10 years old and in grade 6, says, this taught me a lot. Even my parents don't know. I can go on and on with comments. This course is helping students from 7 years old to 70 years old. But don't even take their words. Try it out for yourself and your algebra will never be the same. Check out UltimateAlgebra.com and pass your next test with ease.